Welcome. In this particular video, we'll be analyzing function notation with exponential functions part 5. Let's take a look at our first example. Example 1. Given f of x is equal to 5 halves to the x minus 1, find f of 3. Now take a look at our input value here. Our input happens to be 3, so let's go ahead and substitute that in wherever we see an x. So we have f of 3 is equal to 5 halves raised to the third power minus 1. Now here we need to do the order of operations. So we're going to evaluate the expression with the exponent first. Now we have f of 3 is equal to 5 halves times 5 halves times 5 halves minus 1. So multiplying across, we get that f of 3 is equal to 5 times 5 is 25 times 5, it's 125, all over 2 times 2, which is 4 times 2, which is 8. And this is minus 1. So looking for a common denominator, we can rewrite this as follows. F of 3 is equal to 125 over 8 minus 1 times 8 over 8. So we can have the same denominator. Once again, rewriting this, we get that f of 3 is equal to 125 over 8 minus 1 times 8, which is 8 over 8. And 125 minus 8 will give you 117 over 8. Therefore, we can conclude that f of 3 is equal to 117 over 8. Let's analyze a couple more examples. Example 2. Given g of x is equal to 1/4 to the x plus 5, find g of negative 2. Our input value happens to be negative 2, so let's go ahead and substitute that in wherever we see an x. So we have g of negative 2 is equal to 1 over 4 to the negative 2 plus 5. Now, recall that since we are given a negative exponent, we can rewrite that one as follows. We have g of negative 2 is equal to the reciprocal of the base, which is 4 over 1, and the opposite of the exponent, which is the opposite of negative 2, which is 2, and then this is plus 5. Now, recall that 4 divided by 1 is simply 4, so we can say that g of negative 2 is equal to 4 squared plus 5. Now, rewriting this with repeated multiplication, we get that g of negative 2 is equal to 4 times 4 plus 5. And following the order of operations, we get that g of negative 2 is equal to 4 times 4, which is 16, plus 5. Now 16 plus 5 gives you 21. Therefore, g of negative 2 is equal to 21. And lastly, example 3. Given h of x is equal to 2/5 to the x plus 7, find h of 0. So here our input value happens to be 0. Let's go ahead and substitute that in. So we have h of 0 is equal to 2/5 to the 0 power plus 7. Now recall that any non-zero base to the 0 power is always 1. So we have h of 0 is equal to 1 plus 7. And 1 plus 7 gives you 8. Therefore, we can conclude that h of 0 is equal to 8. So this concludes our video on function notation with exponential functions, part 5. Thank you for watching and have a wonderful day.